Welcome to AI Podcast. Today we're unpacking a new AAAI paper called MOMA, a way to reduce social bias in large language models without trashing their accuracy.
MOMA as in multi-agent, multi-objective. I like the acronym already. What's the gist before we dive in?
Big picture. The authors show you can run a small team of helper agents in front of a model so it answers more fairly while staying effective. In their tests on two well-known bias benchmarks, they cut bias by a lot, and the hit to accuracy was small.
That sounds almost too tidy. Who's behind this work?
Lead author Zhenjie, with Wenqing Chen and collaborators from Sun Yat-sen University, Zhejiang University, and City University of Hong Kong.
All right, set the scene. What problem are they trying to solve that others haven't nailed yet?
Language models pick up stereotypes from the web. Plenty of fixes exist, but many need access to the model's guts or heavy fine-tuning. Others use long-value prompts that reduce bias, but also tank accuracy. And some multi-agent debate approaches are powerful but expensive and slow.
So they want a middle path? Keep the model as is, keep things efficient, and juggle two goals at once: fairness and accuracy.
Exactly. Think of it like driving with two pedals. If you only slam the fairness pedal, you might stall accuracy. If you only press accuracy, bias creeps back in. MOMA tries to keep both pedals balanced.
And the multi-agent part, what do these agents actually do?
Picture a newsroom. First editor redacts words that can trigger biased shortcuts, like explicit group identifiers. That's the masking agent. Then a second editor adds back balanced, neutral descriptors for the groups involved so the story doesn't lose meaning. That's the balancing agent. Finally, the reporter writes the article, which is the base model answering the question.
So it is redact, rebalance, respond. Why not just redact and be done?
Pure masking can throw away signal you need to answer correctly. Balancing tries to restore enough context in a symmetrical way so the model isn't guessing in the dark. The idea comes from a causal view. Break the shortcut between identity words and outcomes, then add controlled, equal information back so the model focuses on the task.
Multi-objective also means they measure both sides. How do they judge fairness and accuracy here?
They use two established data sets. BBQ, which is a question-answering benchmark designed to reveal bias across demographics, and StereoSet, which looks at stereotyped associations, both within a single sentence and across sentences. StereoSet has a combined metric that rewards being accurate while not preferring stereotypes.
What are they comparing against? Because results only matter if the baselines are credible.
They include standard prompting, chain-of-thought prompting, a few anti-bias instruction prompts, self-consistency where you sample multiple answers and vote, and a debate-style multi-agent setup. Importantly, they keep the core model untouched. They test on a modern open model and on a popular API model.
Let's talk outcomes, but without drowning listeners in digits. What changed with MOMA?
On BBQ, bias goes down sharply, while accuracy stays close to baseline. On StereoSet, the combined fairness and accuracy score jumps substantially. In plain terms, MOMA moves the trade-off curve outward. You get less bias for roughly the same level of task performance.
And the efficiency claim. Multi-agent can be a rabbit hole of endless back and forth. How heavy is MOMA?
Lightweight, 2 helper calls before the final answer. No multi-round debates. In their cost comparison, it is noticeably cheaper than debate-style methods and only a handful of calls more than a simple prompt.
I can hear a skeptic asking whether those helpers are just long, moralizing prompts with a fancy name.
Fair question. The helpers are focused on transforming the input rather than lecturing the model. One removes identity cues, the other reintroduces symmetrical neutral descriptions. Then the base model answers the task without being flooded with values talk. That separation seems to cut the alignment tax.
Alignment tax being the accuracy you lose when you try to make a model safer or fairer. Got it. Can you give a concrete example of how this might work in practice?
Imagine a hiring-style question with a line like, "She is a young mother from such and such group." The masking agent strips the explicit group terms. The balancing agent adds neutral traits for all groups involved, things like experienced or dedicated, symmetrically. The model then answers based on job criteria rather than the demographic cue.
I like the newsroom analogy. Redactor, balance editor, reporter. But what about the hard edge cases where the identity detail is actually relevant to the question?
That's where the balancing step helps. Masking might remove too much. Balancing tries to put back enough context, evenly for all groups, so relevant information is preserved without reintroducing stereotypes.
Let's hit the limitations. What should listeners keep in mind before they run off and ship this to production?
First, scope. The paper focuses on English QA-style tasks and 2 model families. We still need evidence in conversational chat, summarization, or multilingual settings. Second, prompt sensitivity. Multi-agent pipelines can depend on the examples you feed those helper agents. Third, metrics. Benchmarks like BBQ and stereoset are useful, but they are proxies. Real harm reduction needs human evaluation in context.
And cost in the real world can shift depending on API pricing and context length, so your mileage may vary.
Exactly. The reported efficiency is encouraging, but deployment bills depend on your stack.
Do they release code or templates?
They point to resources, and a fuller release would help reproducibility. That's a common next step for papers like this.
Speaking of next steps, where does this line of work go from here?
3 directions jump out. 1, broader tests across languages and tasks, with human raters judging fairness in realistic scenarios. 2, measuring information loss directly. How much meaning does masking remove and how much does balancing recover? 3, hybrids. You could combine MOMA with light fine-tuning or post-training to make it more robust under domain shift.
I would add operational guidelines. Teams will want recipes, when to turn masking up or down, how to pick balanced descriptors, how to audit outputs over time.
Totally. Think dashboards that track both fairness and accuracy week by week so you are not flying blind.
All right, quick recap for busy listeners. MOMA uses a small pre-answer agent team to reframe inputs, treating fairness and accuracy as joint goals. It shows large bias reductions on standard tests with only modest accuracy trade-offs, and it does so more efficiently than heavy debate setups.
And the mental model is simple. Redact the shortcuts, restore balanced context, then answer the question.
Final thought. This does not end the debate on bias, but it is a pragmatic step that people can try today on closed or open models. Transparent, API-friendly, and measurable.
That's it for AI Podcast. If you experiment with MOMA-style prompting in your workflow, let us know how it goes and what breaks. Sharing those lessons is how the field moves forward.
Thanks for listening. Until next time.